Tab on this arrow. I think the tab on this is the arrow. One might expect that to be full tab and the arrow. No, it's just pointing to the actual opening.
I think, yeah, I think they're very helpful.
I hope it's good.
Yeah, one of your goes opening them does have a completely full partner.
Oh, let's see.
Very limited timing. I just sent comments on the updated.
We will try to discuss it. Okay, let's get started. So, welcome to AVT Core. I'm Magnus Westlund, and this is Ronny Evan. And this is the note well. So, if you haven't read it, go read it. It's on the IETF webpage. It applies. So, we have a rather light agenda today, so we have plenty of time to continue discussing things if we need to. So the only two topics after this status update is the circuit breakers and an update to the general mechanism for RTP header extensions. So what? Okay, thank you both. So document status. RFC is published, none. However, the topologies update is in authors 48. It's approved by authors, and so we're just waiting for RFC to pop up, but I haven't seen it yet, but it should be any day. As soon as Star said it gets to put it into publication. So AES GSM, I'm shepherding that. It's been stuck on the non-responsive authors there. We will do something to get it unstuck somehow, to get it out, but so it's on its way, but it may take a few weeks more before it can pop out. But well, I mean, if you're going to do an override, it takes 2 weeks, just that. So I think so. Hopefully less, but let's see what happens. So yeah, this is up to 90 something or.
48 weeks, 48 months.
So anyway, so that's that. Do you want to speak for ARIA?
Okay, so we have still the ARIA SRTP. The ARIA SRTP, I mean, I don't know what is the process here, because they just took out, it's a previous document without the SDS inside. Otherwise, it's the same document, and it was at the ISG at the time. So the question, I mean, I think for the area director about what, I mean, should it, we do again IETF last call and finish that? Okay. Okay, okay. And the other one I have to go, we need to start probably to do a last call on that and go finish that also from that one.
Okay. The next three documents I'm co-author, but they all in AD review. So
I have reviewed them. It's just a matter of writing it up and send. So those should go into, I have some comments, but they should go into IETF last call shortly after the week, after the IETF week.
Great. And we have two other working group documents that is not on the agenda and otherwise not specifically discussed here. It's the multiplexing scheme updates for SRTP extensions for DTLS. There's been some discussion on the draft, and I just continue working on resolving those issues and getting updates. So, multipath RTP. What do you want to say, Varun?
So we presented an update at the last IETF. We're working through the updates, and we now have the only announcement I want to make is that we have an open source working version of this with OpenWebRTC. And hopefully, I was hoping to do a demo this week, and I'm still hoping that I could show some people this. And I think next time we'll present it with links to all the open source stuff, and we can progress the document.
So I guess it's, people should review this, including myself. So, but
yeah, and we also got DTLS working, because when we had to get this thing working with OpenWebRTC, we had to like figure out how that mapping goes. So we got that working, and I think we would put that either in this draft or like at least discuss it on the mailing list and see like how we want to proceed.
Yeah, please do that, because we might have to do that work in at least a separate piece or something like that. So.
Okay.
But, but let's talk. Yes. We have two expired working group documents. That's true. So the multiplexing guidelines, I'm one of the authors. We met yesterday and drew out the plan for updating draft. And so the goal here is to, no later than Buenos Aires meeting, have an updated draft, which will reduce the length and focus it much more on the scope of the useful document by an RTP application designer for considering how to use RTP multiplexing. So when you have multiple streams or not, etc., one or more sessions, those kind of questions. So, the AQT document has expired. I don't see John. It's a little bit in limbo, I think, pending a bit more progress in PERC to a certain degree, because nobody in here has been screaming about it for its classical use. So it will probably continue to be a bit in limbo until it gets further on in the PERC working group to see where that's going. So, but if you need it for a classical usage, you better comment on that. So milestones. They are all kind of passed. So we need to update the ones which aren't done or very close to finishing. So we shares will initiate a round of asking authors when they think they reasonably can complete them, and etc. And then we'll present some proposed new milestone dates to working group on the mailing list. So authors, if you already now have some idea on when would be a suitable milestone, you can send it to us. Any questions on the status of the working group? Or the milestones or anything, okay? Then we can move on. It's still hours, I think, until. So at some point we're gonna need to figure out it, but as nothing happens with AQT, it's for the moment it's. But yeah. Okay. You get one of these. So you can flip the slides yourself. Yes.
All right. So I guess I have to stand in the box or bad things happen. So I'm Colin Perkins. This is the RTP Circuit Breakers draft, which we've been writing with Varun for a while now. So this draft has been going on for a reasonable number of meetings now. It was last presented a couple of meetings ago, and we had some extensive discussion with Magnus about a bunch of open issues that he spotted with the previous version. So the most recent update is a fairly major update to the draft to try and address these issues and hopefully have something that should now be ready for working group last call, and also to clarify a bunch of more minor things that Simon and Magnus also found. So the two main areas where there were issues with this draft were regarding the media timeout circuit breaker and regarding the congestion circuit breaker. And these weren't fundamental issues with the mechanisms. They were sort of details and corner cases where it turned out that the simple proposals we had in the previous version of the draft didn't quite work if you configured RTCP in a slightly odd set of, or not so much an odd set of way, but in a perhaps slightly unusual way and hit some corner cases. So the first of these was the media timeout circuit breaker. Now the media timeout circuit breaker is when you're sending media to a receiver and you're wanting to check that the media is actually getting there. So you're sending RTP packets and you're waiting for RTCP sender reports, receiver report packets to come back. When those packets come back, you look at the extended highest sequence number received field in the sender reports and receiver reports and see if that's increasing. And if you're sending packets and the RTCP reports coming back show a non-increasing extended high sequence number received, that's evidence that the packets you're sending aren't arriving at the receiver, which is evidence that the forward path has failed and that something is broken and you should stop sending. So the question for this circuit breaker is, well, how long do you wait if you're sending packets before you see the received sequence number increasing? Before giving up and assuming the packets are not arriving. Right? So the question is, what is some reasonable time to wait? What's the media timeout interval? So what was in the previous version of the draft was that you should wait for the minimum of the floor of 3 plus 2.5 divided by TD, where TD is the TCP reporting interval, and 30 RTCP reporting intervals before giving up. Now, in practice, what that results in is what's shown in the table there, where if your reporting interval TD is 5 seconds, that means you end up waiting for 3 RTCP packets to come back before giving up. And if you get 3 reports, i.e. 15 seconds, when you've been sending media and nothing's been received, then you give up and you assume that it's not going to be received and that something's gone wrong. And it was scaled so as the RTCP reporting interval TD in the table went down, you wait for more intervals, and the time taken to trigger sort of scales. The smaller your reporting interval, the quicker you trigger, but it doesn't quite scale linearly. And in the limit, you ended up sort of triggering in about half a second, which was 30 reporting intervals without receiving anything. Now, there are a couple of cases where that became problematic. The first one is if the reporting interval is small, such that you're potentially sending less than one Not sure this is the right way around, but if your reporting interval is such that you're sending less than one RTP data packet per RTCP reporting interval. Now, in this case, there may be cases where you're sending your media and you're getting reports back saying, I've not received any media. But that's fine because you didn't actually send any media. But as specified here, if your intervals were configured at just the wrong set of values, you could time out because you got several reports in between sending RTP data packets, which would trigger an erroneous timeout. Equally, if the reporting interval became less than the round trip time, there were cases where you would start getting reports back before your data had time to get to the receiver, and you may time out in some perhaps unusual cases, but you may time out if your reporting interval is very small compared to the round trip time before the data had actually had time to arrive. And these didn't seem very common, but they were certainly possible, and it's something we should address. What's in the new version of the draft is that the reporting interval, is that the media timeout interval is now, you take the maximum of the RTCP reporting interval, the round trip time, and the media framing interval, i.e. the approximate time between packets you're sending. And you take the maximum of those, and you take 5 times that, and you divide that by the reporting interval. Now, what that gives you, in the usual case where the RTCP reporting interval is large compared to the interpacket time and the round trip time, that means you time out after you've got 5 RTCP reports coming back saying that the media isn't being received. In the other cases where the RTCP reporting interval is smaller than the round trip time, or where it's smaller than the interpacket interval, you scale the amount of time, the number of intervals you take to time out based on the differences. So for example, if your RTCP reporting interval is ½ a second and you're sending media packets once per second, rather than timing out after 5 RTCP reports coming back, you time out after 10 coming back, because the intervals are such that you'd expect every second report to have to show a packet was received. So we scale things up to compensate. Okay. So any comments or questions on that before we move on to the congestion circuit breaker? So this is the proposal which is in the draft now, as of now. No objections. Yep. Okay. The other issue is with the congestion circuit breaker. Now, the goal of the congestion circuit breaker is to stop flows that are causing persistent congestion in the network. Sure.
Jonathan Lennox, I mean, what do you do if you have a media that doesn't have a regular framing interval?
So there are some words in the draft that talk about that, but essentially you pick something plausible.
Yeah, I mean, because I guess.
So for obviously for constant bitrate stuff, this is easy. Constant frame rate stuff.
Yeah.
Things like audio that switches between speech and comfort noise. There's
I think the extreme case.
I think it says pick the largest of the two.
Yeah.
Pick the comfort noise interval.
Yeah, I mean, wondering about like the various time text things, which if somebody isn't typing doesn't do anything. Yeah.
I forget exactly what we wrote, but there are some words in the draft to try and address that. And someone needs to look at those and check that they make sense.
All right.
Essentially, it just boils down to sort of look at the time since you've last sent the packets and do something reasonable. Equally for time text, I don't think there's ever going to be an issue with congestion, unless someone's typing really quick. Yeah, sure. Yeah, I mean, the draft does have some words. I forget exactly how we phrased it, but do have a look and see if it makes sense. For the congestion circuit breaker, the goal is to stop flows that are causing persistent congestion. The basic principle of operation is when you're sending at more than a minimum rate, you estimate the rate a TCP connection would achieve over the same path based on the RTCP reports that are coming back. And you compare that estimate to the rate at which you're sending. And if you're sending at more than 10 times the TCP estimate, you either cease transmission or you reduce your rate by a factor of 10. So the issues here are then what should be the minimum rate at which this kicks in, and what should be the measurement interval over which you're comparing with TCP. So what was in the previous version of the draft was that the minimum rate was 1 packet per round trip time, and that the measurement interval was that expression up there, which is the same as the one used for the media timeout. The problem with that was that there were cases where the RTCP interval was more than the round trip time, where the minimum rate of 1 packet per round trip time could allow quite a lot of data to be sent without getting any feedback. And for small round trip times, you can actually, for some round trip times, you can actually send quite a lot of data. You get to a pretty high rate and get 0 feedback on it. So that wasn't necessarily a good idea. And the interval, the business with the measurement issue had all the same problems as for the media timeout. What's in the new draft is that the minimum rate is the maximum of your 1 packet per the maximum of your RTCP reporting interval and your round trip time, whichever one is biggest. So in the case where the RTCP interval is more than the round trip time, which is the typical one, if you're sending more than 1 packet per report, you need to start using the circuit breaker. Otherwise, you're limited to 1 packet per round trip time, which is the minimum rate TCP can send out. And is in all the UDP guidelines drafts and so on. So we're basically just adapting it to account for the rate at which you get feedback, which is different in RTP than it is in TCP. You know the round trip time once you've got an RTCP report, and if you haven't got an RTCP report, well, you're in the one of the other circuit breakers is going to trigger, so it doesn't matter at that point. Yeah, and yeah, you'd have to do a conservative estimate, but you'd be in the stage where the TCP timeout breaker would be triggering. But yeah, picking a conservative estimate would be fine as well. The measurement interval, we have what looks like a complicated expression. I don't think it's actually too bad. What it boils down to is you're given at least 10, what we call this parameter G, which is how many frames are independent. So essentially 10 GOPs, or whatever the equivalent is for your codec. You have 10 groups of frames coded together. So it's 10 intervals at which you can actually adapt your sending rate. 10 round trip times. So you've got at least 10 GOPs, 10 round trip times, and 3 RTCP reporting intervals at which you can adapt, all of which is capped, the expression on the right, at a minimum of 15 seconds. So you have at least 15, at a maximum of 15 seconds. So if your congestion controller isn't doing anything sensible over a period of 10 frames or groups of frames, 10 round trip times, and 3 RTCP reporting intervals coming back, whichever of those is the largest, and you're still going 10 times faster than TCP would, then you should cease transmission. Well, as always, it's cease or reduce by a factor of 10. Yeah. And the goal is that the congestion control will have noticed long before you hit this point and will have slowed down. So that's the status. The draft has changed fairly significantly. The new proposals are reasonably big changes on the others. I think they address the limitations we found with the previous version of the algorithm. I also think the draft is better specified and hopefully easier to read and implement than the previous version was. However, they're new mechanisms. They haven't seen a whole lot of analysis, and presumably no one has implemented them as yet. So they're new proposals, but I think they're better proposals. I spent a fair amount of time talking about these with Magnus. My understanding is that he is also happy with them, and they address his comments. So what we're looking to do is go for a long working group last call to give people time to play with these and see if they make sense in implementations and to do some more simulations and so on. But as far as we are aware, these are now done, subject to confirmation that they really do work as we hope.
Jahed Erickson. The implementation and validation, I mean, do you have any plan, or, I mean, as far as I remember, I have evaluated the very early version of this draft, and we found some issues, and now it seems like it's quite a lot of change, as you say, like what?
So it's quite a lot of changes, but I think we have something which is much better motivated than it was before. So I'm reasonably confident that it will work. Certainly, the next thing I'm planning on doing is putting this into our previous set of sort of simulations and rerunning them all with the new circuit breaker and seeing if it behaves the same. I just didn't have time to do that before the meeting.
Okay.
If you're
so
able
you have planned to do that. I mean, you're going to show some data.
That's certainly my plan. And if there's anything noticeably weird about that, then obviously I will come back and say, look, we found a problem here.
Okay.
If people are able to implement it or do other tests, I mean, that would clearly be a good thing as well. The main point, the main question I think at this point is sort of how quickly do we want to move forwards? Do we want to go to just do a long working group last call, or do we want to let this sit for a while and then come back to it later?
Michael Ramallah, Cisco Systems. Just a quick question. I'm reading the document now. I obviously haven't read it really thoroughly, but when you discuss the TCP throughput equation, is the P and stuff that's in that equation meant to be the same exact as RFC so 3448? Because it doesn't seem like it mandates that same method of generating P be used.
The value of P is what comes from the RTCP reception reports.
Okay, so it's a measured probability of loss.
It's an estimate based on the loss fraction in the RTCP reports.
Yes, so it's based on measurements. Okay, because there's other implementations of that equation where the P, which is probability of loss, is actually calculated in a different way. It's calculated based on some sort of weighted average of the intervals between loss events. Sorry about getting all hairy about this, but that particular equation is at least has been our experience to actually calculate the P based on some of the newer references, which is the interval between loss events and not the measured P. That if you actually do the measured P, it's kind of like a short-term measurement of the probability of loss.
Sure.
And that equation doesn't work as well. So my question going to you, Colin, is if you're going to specify an equation that has a P in there, that you ought to, that there should be some text in there to say how you calculate P. And if the recommendation is actually to use the measured P, we've got documentation that isn't the best one to use. So I just bring that up. I'm pretty sure you're familiar with all that.
I agree it's not the best one to use. It is the only one which is available, therefore we have to use it.
Not necessarily.
We have to use it because this has to work with unmodified RTCP. So the only information we have available is the P that is returned in RTCP. The draft does have an averaging process which shows how you calculate P for the congestion circuit breaker in it. But we have to work based on that measurement because that's all that is available, and the goal is to work with unmodified RTCP.
I don't understand why it is that you couldn't calculate it the way that it's been proven to map best.
Because the goal of this draft is to work with unmodified RTCP statistics, so you have to work with the information that is provided.
So
you don't have loss events information.
So no. Okay, I guess I'm worried now about those cases where that equation, because of the way that you're using the measured data, would result in a rate that's lower than the one that you ought to be running at. But I haven't read the draft enough, and I haven't commented clearly. I have not commented on the list. I just asked that as a question.
So there is an averaging process in there. Which may or may not help. I don't know. I mean, it is specified in detail in the draft. But for better or worse, we're stuck with what's reported in RTCP. And yet I agree, if we could change the metrics that were coming back, we could do something better. But for this purposes, we can't change them.
Okay, well, thank you for answering the question.
John Lennox. I mean, the first thing I respond to that is maybe there should be something that if you have better metrics, use those instead to calculate some of this stuff.
Absolutely, and if someone wishes to write that draft, I would recommend that someone do so. But we need a baseline that works with unmodified RTC.
And then the other thing, which I mean, I'm either relaying for Bernard Aboba or not, depending on whether he wanted me to, but whatever, I don't care. I wanted to ask it anyway. Are any browsers planning to implement this? And that's asking the various browser people who I see sitting in this room.
Small aside, Michael Ramallo again. I would agree with your solution that if you have a better way of getting P, that you may use that. So if you want to draft those words, that would satisfy my concern.
I mean, this is certainly not, this is certainly not intended to be the only circuit breaker ever invented. And if someone it comes up with a replacement to this that looks at our TCP/XR information, for example, then I think that would be a good thing, and you could probably do a lot better than this. But we just need the baseline.
Agreed, and that simple text that Jonathan just hypothesized here at the microphone would work for me. Thanks.
So I'm not sure what Jonathan proposed.
If you've got something better, do it, or you could use it.
I mean, that's only leads to inconsistencies in the circuit breaker behavior. I mean, if circuit breaker behaves similar and what you're really expecting to have is a real congestion control, which shouldn't avoid the circuit breaker being triggered, then it doesn't make much sense. So, but.
Yes, I mean, if a future version of RTC Web, for example, wishes to say, we have mandated extra feedback packets, therefore we are also mandating a different circuit breaker, then I think that would be a reasonable thing. But unless you're in an environment where extra feedback is mandated, you can't mandate a different circuit breaker.
Varun Singh, just commenting on the fact that Section 6 says something about extended reports. It does say that there may be some, and we should use them if they, I think it says some text about it. It says if ECN summary reports exist, then we should use them. But I don't think we have a pointer to anything that has the specific loss metric that Michael was alluding to. Therefore, we cannot actually say anything about it.
Yeah, I think what it says is if you're using ECN and you get ECN feedback, you should treat it in the same, ECN feedback in the same way as you treat loss feedback.
Right.
It says, if I remember it right, it says nothing about how you make use of the myriad of other types of
it doesn't,
that is in XR.
Yeah, it just says plug in that same value into the P, right? Basically, that's the interpretation of it in implementation. Yeah. So if there was a better feedback and we could just say that if you got that, then plug that in to P.
Yeah, I mean, I can certainly imagine an extension to this document or another document that says, if you have better feedback information, this is how you use it.
Yes, the crux of the problem is there is no, no one's defined this.
No one has written that draft.
Yeah, that's true.
Michael Ramallo again. I apologize for bringing it up. I haven't used your method of calculating the P, so I don't know its efficacy, but I do know some other things that we've tried internally. At times will generate too low of an estimate that would, had we used it, probably kick the circuit breaker off. But I don't know. I haven't really done the analysis, but I do know that the other ways work a little bit better for us.
I have a question to you. How much? What's the kind of ballpark figure? Is it a factor of 2 or is it like a factor of 5? Or
what happens is that it's a rare event that the measurement conspires, so to speak, to generate a rate in that equation that's lower than you expect. So it's So what happens is that it's not like the long-term average of that equation is wrong with measured results. It's just that every once in a while you'll get a bad series of data, and it will, once every n events, and n events at your packet rate might be once every 3 minutes. Might come to a low rate. So I haven't done the analysis here, so I feel like I'm beating a dead horse somewhat.
So if it's the sort of thing which generates, which repeatedly generates values which are out by a factor of 10 for several RTCP reporting intervals in a row, then I think that's something that we need to be concerned about. If it generates things which are, it's only 1 in 100, or it's only out by a factor of 2, then it won't make the slightest bit of difference.
Yes, the conditional involved here is something you've got to work out with the data rates, the packet rates that you're dealing with. But okay,
I would be interested to see from your analysis how much difference this makes and for how long, because that will tell us whether it's something we need to worry about for this or whether it's just a glitch which will affect one measurement, but that won't trigger the circuit breaker.
And I don't know. And like you said, it's a conditional probability. Once you get this bad measurement event, how many in a row do you need in order for it to and I don't know. So
well, we know how many we need for this. I mean, we know how many we need for it to trigger the circuit breaker. It's this expression here. So it frequently is 3 or 4 or possibly more reporting intervals in a row.
Varun Singh again. I think we've done some analysis, maybe not robust enough, but there are a bunch of papers which have done analysis of circuit breakers, and it's been shown that in a myriad of cases, it does not throw, doesn't trigger it without reason. We could certainly do more tests, and I think that's something that we should do. Like more people running more tests on, like, if we know of a corner case or people can think of corner cases, then alluding to them and maybe running those in both test beds and simulators would be appreciated. And I have a test bed that we could spin up and run if I knew like what the corner case is, because we've been looking for it and we've not found anything that like that stands out and that would require. And some of the fixes that we have here are because of that, right? Because we had the screen sharing and those options where you had really low frame rates, and we've gone back and fixed it. So we can certainly do more in terms of if we would find these corner cases.
Yes. And the previous version of this, I did some analysis, and Varun did some analysis. Zahid did, one of Gary Fairhurst's students did, and I think Simon implemented it. The issues I was seeing were more people saying this is not sensitive enough than that this saying this is too sensitive and triggers all the time.
Jayad Erickson, yeah, I was going to say, like, yes, that was our findings. And in terms of like the p-value calculation, I think Google Chrome congestion control, they use a TFRC based center based approach right now, and they use this p-value as you have described here. So it's actually a live system using it, and I don't think like it would have been a huge issue. They would have been put in a live system. So, and I also in my simulation, I didn't really thought like this is an issue. So unless and until there is a really, really bad corner case, I really don't think like this need to be discussed this much. And also, I don't think like there need to be anything written in this draft, because this draft is because, as you said, Colin, like this is about the basic thing. I mean, you don't have more than this information. So I don't think like, I think this is more common sense, like you use what you need, but I mean, this will pop up. If somebody comes up with a draft or some better idea of calculating p-values for an RTP session, you can obviously use that. Nobody is stopping it. But here in draft, I don't think like you need to do anything extra. I mean, that's my own feeling.
Jonathan Lennox, following up on my previous comment, I noticed the absence of browser manufacturers jumping to the mic here. I do point out that this is a must in WebRTC RTP usage, so you're going to have to implement it sooner or later if you're going to be compliant.
Well, if I'm being cynical, you're going to have to provide RTCP feedback so someone who does implement it won't time you out.
Isn't it a must, Justin Brady, isn't it a must that you must provide some congestion control algorithm, and that this is one that if you don't provide anything else, you must fall back to at least this one?
It's actually a must implement this.
So yeah, 7.1 of RTP usage, WebRTC endpoints must implement their RTP circuit breaker algorithm that is described in IETF94 RTP circuit breakers. No conditional on it.
Must implement that, it's not a must.
Well, yeah, I mean, and I guess it's the, and this is basically what you end up if I mean, obviously, if you're talking to somebody who doesn't support your other congestion algorithm, this is your fallback. I mean, hopefully, and I think the idea is you always run it, and if you have a real congestion control algorithm, it should never trigger.
Yeah, I mean, the interval here is designed to be such that if you have a real congestion control algorithm, that will have adapted long before this triggers.
Michael Romalo again. Only a question. If it is a must, then I think you need normative language as to what acceptable ways of calculating the PR and just not just assume that it's going to be.
It does have normative
Okay.
language for that.
Okay.
Yeah, and just going back to the congestion control thing, I think RMCAT even says that all congestion control should work within the envelope of a circuit breaker. So it is kind of, I think if people evaluate their congestion controls to work, like the browsers or whoever is like making their congestion control, if they seem to work within the circuit breaker, then you kind of get that by default. So
Yes. So certainly if we do go to last call with this, we should probably also feed that to RMCAT and ask them to evaluate it.
Jahid Erickson. I mean, yeah, what you said, Bernard, is right. I mean, but the requirement says like RMCAT congestion control should work in envelope. So even if people has not been implementing the circuit breaker, we need to do that. And perhaps in the evaluation of RMCAT, we need to be now be more strict about like having in RMCAT they should actually provide results like that. This works. This doesn't break their congestion control algorithm. But looking at the draft at that time, personally, I didn't thought like I should actually put an effort to really to implement these things in open RTC or stuff that we do like to see if things works. But if it is in a really good state, we really definitely need to do that. But depending on like, I mean, now we're talking about these changes. We're talking about like the p-value. I'm still not sure. Like, I'll invest my resource to really implement it right now.
I mean, this is based on the information that you already have in RTCP, so it shouldn't be too big an implementation challenge. So I think it would be useful if the RMCAT proposers could implement this and see how it interacts with their outcomes. You should have the information to do that available. So.
Okay. So next steps here. My inclination would be to actually run a very long working class call, like 6 weeks. And that's because we have a significant long list of documents that depends on this one. And I think we need to set some deadlines for actually doing these reviews and checks, etc. So, and I think that will probably work best with a working class call. So,
this has been, I don't disagree with that. I was going to ask, when you want the working group last call to allow for implementation and validations, will there be people that will line up and say, I'm going to implement and validate this during that period?
Yeah,
I am certainly going to rerun my previous set of simulations with this. It would be useful if more people could.
Colin, there were also comments from Vibe that implemented that you should probably try to ask them to. Simon, he had comment about the previous version, so he implemented.
Yes, I mean, there was an implementation of the previous one, and the feedback I got was there were issues with implementations not sending out TCP when they should, which clearly caused problems. But the congestion circuit breaker never triggered, so clearly this wasn't being too sensitive.
Yeah. Well, so I will go forward, starting a working class call, 6 weeks, and I will CC RMCAT on this and RTC Web. So. Here, we have the clicker for the slides. Side arrows.
Okay. We I think it was in the music, right? We, as part of the
AVTX.
AVTX was offered. We decided that we need to add support for RFC 5285, which is the header extensions, RTP header extension, to allow support for mixing single byte and double byte RTP headers in the same RTP stream. So we added this text inside the document. In order to verify backward interoperability, we defined a new SDP attribute that allows the negotiation of this mode with systems that do not support the mixing and will be confused by getting a mixed RTP header extension, a 1 byte and 2 byte RTP header extension. This works well for offer answers, and the text there also say that for systems who do not support offer answers like declarative SDP, they should use this mode only if they are sure that the recipients can support receiving both 1 byte and 2 byte header extension, because otherwise there's no way for them to know that based on negotiation. So this is the major change. There were some comments from both from Colin and from Dave Zinger, who is the original author and is co-author of this draft about the document, and that's why the text that was changed based on that. So currently, it's not a big change. So basically, if we think what we'd like to do is to adopt it eventually as a working document.
Jonathan Lennox, I don't disagree with anything you said. I sent a bunch of comments like 5 minutes before the meeting started, and I'm sorry for not sending it earlier. I don't know if you want to speak to those now or.
Yes, please. We have the time.
Okay. Actually, do you have that email in your? Can you pull it up on your laptop so I can remember what I said?
Okay. I see. Oh.
What? Yeah. No. 5 minutes since the meeting. 5 minutes before the meeting started. That's at least an hour ago. Oh yeah, I know, but then other people can see it too. Thank you. Yeah, so I think one of the points was, we've talked about this in the past, is something we were grumpy about with header extensions. There's language in there which, I somewhat tendentiously say, header extensions must be useless, which is to say must be ignorable without affecting interoperability. I think we want to alter that to say, must not change the semantics of other parts of the RTP packet, but it's perfectly fine for them to have metadata that's essential for interoperability. The exact wording of that we need to wordsmith, but I think that would have been, if we had that, it would have prevented a lot of arguments, I think.
But I think the issue there was that the reason was that you allow intermediaries to just drop.
Yeah, I think we shouldn't.
And to just drop header extensions, and now you're asking them to be more, to know what they're dropping on what to drop.
Yeah, I
to
think
add some mechanism by which to mark those.
I don't want intermediaries to be able to drop them. I think that's stupid.
That's now Colin will have to step up, because that's.
I mean, Colin Perkins. I mean, that was put in there because there were intermediaries which dropped them. And certainly, if you have a middle.
I assume not individually, but just the entire XBit and the entire header extension.
Right, and there are lots of environments which we're envisaging now where if you have a middle box, the header extensions will go between the endpoints and the middle box, but they won't go across the middle box.
Right, that middle box is presumably part of your signaling negotiation too, right? I mean, if that middle box is the endpoint of your SDP, then that's fine, right? You negotiate with the middle box, and the middle box negotiates with the other leg.
Sure,
that's fine.
Sure, but if someone has put an RTP relay in and hasn't told you about it and is stripping these off, and that was the issue at the time, is that people were muching about those devices.
The text can be more lenient, saying
no longer exist. Then maybe.
Yeah. Okay. Well.
I mean, you can have some text that says that you better but you cannot really depend on that, and that's the
I mean,
problem.
I think
That's why we're doing all this.
And I think our current solution of put it in header extensions and also RTCP, which seems to work fine for this. And that means that if your header extensions die, you get a little bit delayed. And it also means that if a source is not currently sending, you find out about it earlier. So that's, maybe we don't need to do that, but it just, maybe that just needs some wordsmithing, because it feels right now a little bit too much like must be useless.
No, so that's we can put a better language saying that it's good to have them go through, but again, it won't solve the issue, because you still need to have the fallback mechanism of having maybe an RTCP in order to guarantee to have more chance of delivery of the message. Anyhow.
And then the other 2 points which I wrote about there is, at least the ones that are currently on the screen, I don't remember where they're, is that in 5285, the 2-byte form is optional. Only the 1-byte form is MTI. It sounds like we both need a way to determine definitively whether the other side supports 2-byte form, and maybe we also want to make 2-byte MTI as well. I mean, given all the things we're doing, like with SS header extensions, which would need it in some cases.
So currently, I mean, for the 2-byte, you negotiate them in SDP.
Well, it doesn't actually explicitly say that. I mean, you negotiate the IDs. I guess the idea is if you negotiate an ID outside the 1 to 14 range, therefore, you support 2-byte. I mean, I think does it say, must not negotiate an ID in the outside 14 if you don't support 2-byte?
No, just say that since you have to register, I mean, today, all the new ones, you need to register them with URI and then declare them in the, negotiate them in the SDP. So that's how you know if it supports. It's not a general 2-byte, but it supports these specific ones.
Clearly, but the point being that, I mean, the issue which people are concerned about is, you have a variable length header extension, and so, I mean, that's why we have these changes. Suddenly, its value is longer than 16 bytes, so you need to switch to 2-byte form with a low ID. There's no way to negotiate to know whether the other side's going to be able to receive that or not.
So you mean in that case you need to negotiate, but otherwise that the other side support in general. The general support.
Exactly. Yeah. And then the other question is, do we want to just say that all new implementations must support the 2-byte form? I mean,
I'm all for the later one personally, but that's.
I mean, clearly that's not going to fix 5285 compliant endpoints, but. Going forward, it probably makes life easier.
It's not a big implementation burden to implement both 1 and 2-byte headers. It's really just the headers that is. The rest of the functionality is the same. So.
Yeah.
So.
I mean, I think
So we can the first text about having to say something that if we'll need to have a new attribute that says they support 2 bytes in
either
general.
You have a new attribute that does it, or you just. I think the usual.
Or if this new, I mean, you want to tie it with the mixed mode. You want to.
Yeah, well, the problem is there might be existing 5285 endpoints that do support 2-byte headers.
Yeah, no, I understand.
Yeah, which won't do this attribute.
Which won't do that.
Yeah, so maybe,
but then
the argument has been negotiate something that you couldn't represent in a 1-byte attribute. You basically use a ID greater than 14.
Yes.
And then see if the other side will negotiate that as the heuristic for that.
So you said that it may be implied that if you have an ID greater than 14.
If you've said you can,
but still that doesn't solve the whole issue, because I mean I understand what you're saying. If you negotiate initially the support for this specific header extension, then you want to switch from 1 byte to 2 bytes. Okay.
Yeah.
So anyhow, you cannot just switch arbitrarily. You only can switch for ones that you were already decided that you do, and you just want to know that the 2-byte is generally supported by the other side. And to have some text that says if the ID now for the same ID, how do you know? So you'll have to specify both IDs at that. I mean, that's not.
Yeah, no, I mean,
you cannot do that without signaling, basically.
Yeah, no, this would be with the signaling. I mean, I'm just saying that to try to, if there's a way we can do it with the signaling in a way that would be hopefully backward compatible with sort of relying on implicit behavior of 285. I mean, so.
A personal comment from him. I mean, I think if your the information you intend to send in a header extension requires you to use the long format, the 2 bytes, then I think you should really or must use the value above outside the range.
Right. I mean, the worry is like if you've got something that's,
Exhausting of the one.
if you've got, I mean, and maybe this won't happen. I'm just worried about some case where, you know, you've got something that's variable length.
Yeah.
And you don't know in advance whether you're going to
Yeah.
need to cross the 16-byte boundary or not.
But then in that case, I think the reasonable thing is to use the proposal which is in Ronnie's draft, or I say Ronnie and David said the other authors draft, is to use that generic signaling saying, oh, I support the updated spec. That's basically what you're saying. So I can do both 1 and 2 bytes. And,
Okay, yeah. So yeah, all right, that makes sense.
Yeah.
Okay, that makes sense. And then, but the other point I had is we should just cite the header extension encryption
Yeah, okay.
spec.
The security.
Yeah,
that's
basically in
not-
the security considerations. So
Yeah,
that, you know,
that
with
makes
the
sense.
usual, you know,
As long as we are updating
Yeah,
the
exactly.
document, it makes sense.
and say, you know, yeah, you have to say whether you need to use them or not when you define that header extension.
Okay.
All right, okay, that's the points I made. So
Any more comments on the draft? Then I think we should see if you support adopting this as a workgroup item. Any more questions around that, or what the purpose? Do you understand why we're updating this? So let's hum about this. I will ask about who supports adoption, and then if there's any opposed. So do you support adoption of this draft as a working group item? Hum now. Fair amount of hum. Who opposes? Hum now. Silence from my perspective. So seems to be good support for adopting this. I'll work with the AD to create milestones, etc. So yeah. Okay, good. No, nothing ever. Okay. So okay. Do anyone has anything else they want to discuss in AVT Core? No. Well, then we conclude. Thank you for today.